Hi guys, welcome back to my YouTube channel. Let's crack real math. My name is Viraaj, and in this video we'll be having a look at discrete random variable, mainly in terms of, or mainly the first part of it, that is tree diagrams and the probability distribution table. The other part of it, which includes variance and expectation alongside standard deviation, will be done in a later video. So today our main focus is only at the tree diagram and the probability distribution table part of it. So without further ado, let us begin. So to begin with, what is a tree diagram? Tree diagram. Now, a tree diagram is a sort of a representation of probability in a way. So let's say, for example, I have in a bag, I have, let's say, 5 blue pens and let's say 3 red pens. And I am to choose, and I am to take 2 pens out of the bag without replacing any of them. So without any replacements, I am to take 2 pens out. And I need to now, let's say, represent this sort of scenario in a tree diagram. So we know that the total amount of pens in the box is, in the bag rather, is 8 pens. So the probability of me either taking a blue pen, let's say this is blue pen, or taking a red pen. For blue pen, the probability is 5/8 because there are 5 blue pens in the bag, and then the probability for the red pens is 3/8 because there are 3 red pens and total amount of pens is 8. But emphasis again, because I said that I'm taking 2 pens, and what I've done so far is just for 1 pen. So if I was to now take another pen, let's say from here we would have 2 more scenarios, and from here as well we would have 2 more scenarios. So what would now be the probability of me taking another blue pen if my first pick was a blue pen? If my first pick was a blue pen, that means instead of 5, I would now have 4 blue pens in the bag. So I would now have 4/7. Why 7? Because we had a total amount of 8 pens. But because we took out a blue pen, we now just have 4 blue pens and 3 red pens left, and 4 plus 3 is 7. So that's 4/7. And if in my first choice I got a blue pen, what's the probability I would get a red pen in the second pick? And that would be 3/7. Because the amount of red pens is still the same, and total amount of pens reduced because my first pick was a blue pen. Now, if my first pick was a red pen instead, what would be my probability of taking a blue pen or taking a red pen? If my first pick was a red pen, then my probability for taking a blue pen would now be 5/7. Because since my first pick was a red pen, the amount of blue pens are still the same, but the total amount of pens in the bag reduces because I took a red pen out. So that becomes 3 minus 1, that's 2, and 2 plus 5 is 7, hence it's 5/7. And the probability of me taking another red pen if my first pick was a red pen as well, it would now be 2/7. Because after taking a red pen in my first pick, it decreased to 2, and the total amount of pens now would again be 7. Usually tree diagram questions won't give you much more than 3 picks. So in this case I did 2 picks. And another question could ask you a third pick as well. So you would just have to extend the tree diagram a bit more for each of them, but the question should never go beyond that, and if it does, that means it's probably another method apart from a tree diagram that you would have to use. So in a nutshell, that's what a tree diagram is. Now the other part that I was talking about is the probability distribution table. Let me just call it probability distribution table, PDT. Now what this probability distribution table is, it's a representation of, again, probability, just that it's in a tabular form. So let's say, for example, the most common scenario that then most questions is the one with a die. Let's say a die with 6 sides, that's 1, 2, 3, 4, and 5, and 6, is rolled. What's the probability of landing 3 or 4 or 5? What's the probability of landing what's the probability of each of those numbers to be landed? So we can create a table in such a way that we can let x be the number that's thrown. So that would be just a second, right? So that could be either 1, that could be either 2, that could be either 3, that could be 4, it could be 5, it could be 6. And then the other part at the bottom can now represent as the probability, that's P, of our capital X, big letter X rather, to our small letter x. This is how you write it in a probability distribution table. And if the question said it's a fair die, that is not biased, then we all know that the probability of landing each of the sides is 1 over 6. 1 over 6, 1 over 6. Now, what if the question said that it's a biased die? That maybe one side is more likely to be landed upon rather than the others. In that scenario, most likely what the question would do is that they would give you an unknown variable, maybe in one of the places over here, maybe k or x or any variable. But the best way to sort of deal with those type of questions is to know the fact that if you sum up everything over here, it should always give you 1. So suppose maybe I didn't know what this was. I didn't know this was 1 over 6. It was, let's say, x. Of course, using common sense, you know it would be 1 over 6. But what if we now say, okay, the 5 was not 1 over 6, the 5 was 3 over 6. What's the chance of getting 6 on that biased die? So all I would do is add up 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6 plus 3 over 6 plus x equated to 1, and using algebra solve for my x and get the value out. So that's how a probability distribution table looks like. So that's the basic fundamentals. This is a topic that's much better understood when examples are done. So let's dive right into our first example. Alright, so the first example says, consider a situation in which, by mistake, 3 faulty fuses are put into a box containing 2 good fuses. Okay, good to know. The faulty and good fuses become mixed up and are indistinguishable by sight. Okay, you take 2 fuses from the box. What is the probability that you take no faulty fuses, 1 faulty fuse, 2 faulty fuses? Okay, so this question may look a bit complicated at first viewing, but let's bisect it. So it says that in a situation where, by mistake, 3 faulty fuses are put into a box containing 2 good fuses. So that means the total amount of fuses in that box is 5. They get mixed up and you can't separate them, and you have to take 2 fuses at random. And they're asking you the probability of getting no faulty fuses, 1 faulty fuse, or 2 faulty fuses. So because it says you take 2 fuses, that means we can say that we get 2 picks, just like the earlier example I stated with the bag and the balls, with the pens, sorry, bag and the pens. So because I can see that and I can relate with it, I know that this is a tree diagram question, and it will be much easier to go with it the tree diagram way. So we know that whatever we pick, we can only pick 2 things. Either it's a faulty fuse or it's a good fuse. So let's say this. Let's say one of our picks is the faulty fuse. Let's say that's F. And let's say the other pick is the good fuse. Let's say that's G. The probability of picking a faulty fuse on our first attempt is 3 over 5. Why? Because it said there are 3 faulty fuses and they're mixed with 2 good fuses. So 3 plus 2, that's 5. That's the total amount of fuses. And the faulty ones are 3. Likewise, for the good fuses, it will be 2 over 5. Because it said there are 2 good fuses and the total amount of fuses is 5. That's from our first pick. But it said you take 2 fuses from the box. So now let's look at the second picks we will have. Right, so for our second picks, if I was to take a faulty fuse in my first pick, what would be the probability that I would land another faulty fuse? And that would be 2 over 4. Because we had 5 originally, and I took out a faulty fuse, so that would reduce the amount of fuses in the box to 4. And because I took a faulty fuse, that would reduce the amount of faulty fuses from 3 to 4. So that's 2 over 4. And if that's 2 over 4, then I would know that for the good fuse, it would be 2 over 4 as well. Another way you can know and do this question is that if you know one side, let's say over here, just subtract this from 1 and you would know for the other side as well, which is 2 over 4. That's another trick you can use. Again, if my first one was a good fuse, my first pick was a good fuse, and was the probability of getting a faulty fuse, and that would be 3 over 4, because again, the amount of fuses reduced in the box to 4, and there's still 3 faulty fuses, so 3 over 4, and the chance of me getting a good fuse would now be 1 over 4. So I just took 1 and subtracted that by 3 over 4 to get my other side, which is 1 over 4. Other side, or as they call it, the other branch in this tree diagram. So that's how the tree diagram looks like. But mind you, we have not solved the question at all yet. We have just drawn the tree diagram so that we can have a better understanding of the question and make it a lot easier to solve. So for the I part, it said, what's the probability of getting no faulty fuses? That means I pick, in both my picks, I only get good fuses. The probability of me picking a good fuse in the first pick is 2 over 5. And the probability of me picking a good fuse in the second pick is 1 over 4. So all I would do is simply take these two and multiply them. So 2 over 5 times 1 over 4. And that would give me, when there are 2, okay, that would give me 1 over 10. So the probability of me picking 2 good fuses is 1 over 10. If you recall, in probability, when they use the word AND, you know that they're referring to multiplication. And when they use the word OR, you know they're referring to addition. Now in the question, it didn't directly state AND, but you know that in order to get no faulty fuses, your first pick must be a good fuse, and your second pick must be a good fuse as well. Hence, we do 2 over 5 times 1 over 4. For the I part, it said 1 faulty fuse. So there are 2 ways you can get a faulty fuse. Either your first pick is a good fuse, and then your second pick is a faulty fuse, or your first pick is a faulty fuse and then your second pick is a good fuse. So we'll have to consider both of the scenarios. Let's look at the first one first. Let's say our first pick is a good fuse, that's this, and our second pick is a faulty fuse, that's this. So the probability of that would be 2 over 5 times 3 over 4 plus the other pick, which would now be that I first pick a faulty fuse and then I pick a good fuse. That's 3 over 5 plus 3 over 5 times 2 over 4. And you can directly punch this in your calculator. So let me just do that real quick. That should give me 3 over 5. That's my mental math. Let me just confirm real quick. Yep, it is 3 over 5. because this question can be a bit misleading. You might just go with one of the scenarios saying, okay, my first is a faulty fuse and then my second is a good fuse. Let me just add them, let me just multiply them both together. But you need to also look at the other side. You can either have a good fuse and then a faulty fuse in your first pick, or hence the addition of the two products, you can have a faulty fuse in your first pick and a good fuse in your second pick. So on to the I part of this question. And this says, what's the probability that you take two faulty fuses? So that's simply this multiplying this. So 3 over 5 times 2 over 4, and doing this should give you 3 over 10. 3 times 2 is 6, 5 times 4 is 20, simplified to 3 over 10. And that's the answer for that particular question. On to the next example. Right, so this one says 2 fair tetrahedral dice. Okay, tetrahedral just means 4. It has 4 sides, each with faces labeled 1, 2, 3, 4. Yeah, as stated, just 4 sides are thrown, and the random variable x, okay, is the product of the numbers shown on the dice. Okay, good to know. Part I says find the probability distribution of x. Now when they say find the probability distribution of x, they're simply wanting you to find the probability distribution table. Now before I go into probability distribution table, this question requires us to do something else. It says 2 fair tetrahedral dice, each with faces labeled 1, 2, 3, and 4 are thrown, and the random variable x is the product of the numbers shown on the dice. So what we can have now here, if I were to throw, because there are 2 dices, so we can have something like this. Here, here. Okay, I have 1, 2, 3, or 4. Likewise, I can have 1, 2, 3, or 4. Let these two separate 1, 2, 3, 4s represent a die. So we just create a mini sort of table here, which would greatly aid us in solving this question and questions similar to this. Now, if my first die was to give me 1 and my second die is to also give me 1, and it said that the random variable x is the product, not the sum, the product of the number shown on the table. So I would know that 1 times 1, that's 1. If my first die was to give me 2 and my second die was to still give me 1, the product of the 2 is 2, because 2 times 1 is 2. Likewise, 3 times 1, 3, 4 times 1, 4. Here I would do 2 times 1, 2. If my first die was to give me a 2 and my second die was to also give me a 2, the product of the 2 would be 4. 3 and 2, 6. 4 and 2, 8. Then 3 and 1, 3. 3 and 2, 6. 3 and 3, 9. 3 and 4, 12. 4 and 1, 4. 4 and 2, 8. 4 and 3, 12. And 4 and 4, 16. Now you can also do this type of question when they say that the random variable x is the sum of the numbers shown on the dice. That's a little bit easier, but it's also possible for them to say product, and in this case they said product, and that's how the sort of table looks like. Mind you, this is not the probability distribution table, this is just another table that we did on the side, so it can help us draw the probability distribution table. Now set the random variable x, so we can say x is our random variable, and as you know, we create our sort of table here. That should be enough. Over here we'd have probability of our big X equaling small x. Closing this, and we can just, yep. Now, what are the numbers, or what are the products that we found? We found 1, 2, 3, 4, we have a 6, we have an 8, we have a 9, we have a 12, and we have a 16. So we can group that in ascending order, obviously. 1, 2, 3, 4, 6, 8, 9, 12, and 16. Just extend this, and we can now just close this. Please make sure that when you are doing this in your exam, your table is neat and everything is seen visibly and clearly. Right, so for 1, what's the probability of having 1 as the product of the two dices? Sorry. So we have 1 occurring only once out of 1, 2, 3, 4, 1, 2, 3, 4. So 4 times 4, that's 16. So the probability of getting 1 is 1 over 16. Because the total amount of scenarios we can have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And the amount of times I'm seeing 1 here is just once, so 1 over 16. For 2 now, I can see 2 twice. I can see a 2 here, and I can see a 2 here. So that's 2 over 16. And 2 over 16 is the same as 1 over 8. So 1 over 8. For 3, I can see a 3 here, and I can see a 3 here. So that's 2 over 16 again, which is the same as 1 over 8. For 4, I can see a 4 here, I can see a 4 here, and I can see a 4 here. That's 3 over 16. 3 over 16. For 6, I can see a 6 over here, and I can see a 6 over here. So that's 2 over 16, which is the same as 1 over 8 again. For 8, I can see 1 here and 1 here. Again, 2 over 16, same as 1 over 8. I can only see 1, 9, so that's 1 over 16. I can only see 1, 12, so that's 1 over 16, and I can see only 1, 16, so that's also 1 over 16. And that is the probability distribution table of this question of the part I. Just to be on the safe side, you can add up all the numbers over here and see if they give you 1. If they give you 1, that means your probability distribution table is absolutely correct. If they don't give you 1, then go back and have a count, because sometimes we can mess up our addition. Even though it seems easy, it can get a bit difficult at times. So that was for part I. Now it says for part I, it says, what is the probability that any throw of the dice results in a value of x, which is an odd number? Okay, so for the value of x, these are our values of x, and it said odd number. So the odd numbers I'm seeing from these value of x is 1, 3, and 9. So all you do is simply add up the probabilities of these 3 odd numbers of 1, 3, and 9. So for 1, the probability is 1 over 16, plus the probability of getting 3, that's 1 over 8, plus the probability of getting 9, that's 1 over 16. So go ahead and punch this in your calculator. I think it should give you 1 over 4, but let me just confirm real quick. 1 over 16. Yep, 1 over 4. So the probability of landing an odd number, like of landing the two numbers whose product would be an odd number, is 1 over 4. So that's the answer for that question. And on to the final example for today, and this is a challenge question. Challenge question. So do pause the video and have a go at this by yourself. and then resume the video to see if you are correct or incorrect. If you are incorrect, please take note of your mistake. So the question says an irregular die. First thing I'll say, it says that's an irregular die, meaning that the probability of landing a certain number is not the same. It's not constant among all the probabilities. It's a biased die. An irregular die with 6 faces produces scores x, for which the probability distribution is given by x. Probability of x to r is equal to k over r, and for the values of r, which is 1, 2, 3, 4, 5, 6, and p of x to r, for which is 0, is otherwise. It says part I, and that's the only part. It says find the value of k. Right, now they're telling me that the probability of landing a particular value is equal to k over r, where r are the values 1, 2, 3, 4, 5, 6. So to set up a probability distribution table, I can quickly say, okay, we have r over here, right? We just draw a line here. At the bottom we have the probability of our big X to r in this case, which they're saying is k over r, and all our values of r, that's 1, 2, 3, 4, 5, and 6. And if we just break this, okay, let's do that again. And if we break this to their separate columns, it is saying that the probability of them landing that particular face is k over r. So this would be, in this example over here, this would be k over 1, because our r is 1 and k over 1 is the same as k, so we can just write this as k, because anything over 1 is k, is the thing itself. So if it's 2 now, for example, we would now have k over 2 for this one, because it said it's k over r, that's the probability, and our r over here is 2, so k over 2. Next one, k over 3, again same reason. After that, k over 4, and k over 5, and k over 6. And it's said to us to find the value of k. Now if you remember, in the beginning of this video I told you that all the sum of these numbers would always give you 1, and you can use this fact to find unknown variables, and in this case we only have one unknown variable, and that's k. So this is basically literally telling me that k plus k over 2 plus k over 3 plus k over 4 plus k over 5 plus k over 6 is equal to 1. And I now need to just solve for k, and that shouldn't be that hard, to be honest, but I'll do it. A few people might decide to go for the least common multiple of 2, 3, 4, 5, 6, which is correct, yes, but it's really time consuming, and in an exam time is of the essence. So instead, just factorize it. Just take k outside and factorize this. K times what would give me k? That's 1. K times what would give me k over 2? That's 1 over 2. K times what would give me k over 3? That's 1 over 3. And same, 1 over 4. 1 over 5. 1 over 6 equals to 1. If you expand k by all of this, it would give you back everything that's over here. And if you just add up everything on the inside, just quickly do that with the calculator. 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6. That's k into 49 over 20 equals to 1. So our k is equal to 1 over 49 over 20, and this would just replace this at the top, so now it's become k is equal to 20 over 49, and that is your value of k for that question. Again, just to quickly explain it, it said that the probability of getting r for these values of r is k over r, and for all those values of r I just took k and used those values of r as a denominator and use k as the numerator, and after that I know all of this adds up to 1, so just equate it to 1 and solve for the unknown variable. And doing that using your algebra, you should get the answer as k is equal to 20 over 49. And that brings us to the conclusion of this video. So thank you for watching. Hopefully you enjoy it. Please do not forget to perform an LSS, that is like, share and subscribe. Also a shout out to YouTube channel Joe Mystery. Do check it out for any chemistry help you may need. Thank you for watching. Have a nice one.